Okay, hello everyone. I'm Huan from Calgary. Today I want to talk about how to use two redundant IMUs to increase the magnetic disturbance robustness. So for research, first you have to find what is the problem, then how to deal with this problem, what you want to get, what you want to obtain, then what kind of method used. Last, you have to prove it by the simulations or by the tests. Okay, what problems we have for the measuring during the drilling or subsurface sensing? First, the traditional method is a Kalman filter. As our well known, the Kalman filter will have a very low robustness to the unknown interferences, because you have to decide the Q and R to get the proper gain for the Kalman filter. Then, for the drilling, for the petroleum industry, it's very hard to do the field calibration for the sensors, for the measurement sensors. Then, because the magnetic disturbances, people get very low accuracy on the position estimation. Okay, so for our objectives, for our purpose, we want to obtain a hardware can measure the proper orientation angles and positions. Then we want to obtain a good method and software. Finally, we want to get really good position estimation with this system. Okay, what kind of hardware we used? We cannot design the details of the sensor, so we use the commercial one, analog devices with the 3-axis accelerometers, 3-axis gyroscopes, and 3-axis magnetometers. The feature is we put a distance between these two redundant sensors. Okay, here is the real system. Because we need to put it into the subsurface, so we need a long distance transfer. This is a long distance transfer. We use the RS485 standard and a Arduino system to make it realizable, like this. Now it's only 100 feet long cable. If you want, you can extend it. Just add some Arduino system. Okay, how to test the data, how to test the sensor, how to calibrate the sensor. We use our system. This is a tester. Now I just show you the 2D movement. You can see it's very accurate because it's controlled by the controller and feedback by the encoders. Why we do the 2D? Because for the test, we only do is a horizontal, and I will tell you the reason afterward. So what kind of method we are using? Wow, it's complex. Actually, it's very simple because we have two redundant sensor sets. We only decide the weight of these two sensor sets. How to decide the weight? Usually, the fuzzy is perfect. The fuzzy is, if you have experience, you can tune the fuzzy very good, but it's very manually. It's not realizable for the real case. So we hire ANFIS to do this automatically. We use ANFIS to get the weights. Use this TG signal to use ANFIS to get the real weights of these two sensors. Then these two sensors, the output will be proper. This is a two structure. The second structure is an ANFIS. The low structure is a traditional Quaternion Kalman filter. Why use Quaternion? Because Quaternion can avoid the Euro angles problem, gimbal lock. So people use Quaternion, but the Quaternion Kalman filter still be a Kalman filter. It still have the problems of the usually Kalman filters problem. Then, after we get the proper angles, we put the angle into the traditional or the present industry using method, such as minimum curvature method or splines. Splines, the best splines is proposed by Abdurban in 2016 with the ASC model. You can check the reference. Now I don't introduce too much about this. So for whatever the present industry method, you need the orientation angles, inclination angle, and azimuth angle. Then measurement depth to get the positions. Here, we use a tester to move the sensor 180 degrees, and we put the magnetic disturbances only affect one sensor at the same time. We can see here we have two sets of data. This data, the magnetic magnitude of the disturbances is in the training range. The black solid line is ANFIS. You can see it has a very good result. Okay, if the disturbance is over the training range, what it will be? It'll still be good, but a little bit get worse because it's over the training range. So the simulation is good. How about the test? We did a test on the UC's campus. We set up 3 magnetic disturbances, and we use 2 disturbances data to training, and use 1 checking. You can compare them. For example, A, if you use A and C to training, then you use B to checking. If you use A and B to training, then you use C to tracking. So from this word, we can see the Quaternion Kalman filter cannot induce the magnetic disturbances. When you have the magnetic disturbances, the Quaternion Kalman filter will drift a lot. But because we have 2, and we use ANFIS to decide the proper weight of these 2 sensors, so the ANFIS signal can keep the correct weight. Okay, now you can get good angles. What is working to the positions? We did more tests on the campus. We use GPS to know the error of our proposed method. The sensor was put on the car, and the computer to record the data. We use row measure to do the measurement depth for 1 meter each. Use this to measure each 1 meter is stop and record. For the traditional method, without magnetic disturbances, we compare with GPS signal. It has a error, still has error, about half meter, like that. Why? Because the IMU sensor error. You cannot calibrate the IMU sensor to zero error. So this error will cause the position due to some drift or errors, but it's not big. We can induce it in the industry level. However, if you have the magnetic disturbances, like the black solid line, it will drift the results a lot, but because we only use a magnetic meter to get the azimuth, that means it only affects X and Y positions. For the Z position, the vertical position, it doesn't affect, because the vertical position is decided by the inclined meters. So that's okay. Horizontal directions, it affects a lot. With our method, the ANFIS, as shown in the dashed blue line, is remove all the errors. It puts the sensor into the correct way. Why it still have error? Because we use the the traditional position estimation method, so it cannot remove the error which caused by IMU sensors. However, this method will have assumptions. What assumptions? If two sensors were affected, both affected by the magnetic disturbances, it doesn't work. That's a limitation. So also, we need high accurate reference data such as GPS, or for the variable, you need the survey data to train it to get the proper gain of the ANFIS. In this research, we designed the hardware of a sensor system, then we designed the software of the sensor system. And based on the results of simulations and tests, it's good, it can be used. Thank you.